السلام عليكم ورحمة الله وبركاته أبناء الطلبة والطالبات. إن شاء الله درس جديد من سلسلة دروس للstatistics moments kurtosis and Skewness coefficients. المومنتس in mathematics, the moments of a function are certain quantitative measures related to the shape of the function's graph. If the function is a probability distribution, then the first moment is the expected value or mean, the second central moment is the variance, and the third standardized moment is the skewness, and the fourth standardized moment is the kurtosis. The mathematical concept is closely related to the concept of moment in physics. Kurtosis is the measure of the tailedness of the probability distribution of a real-valued random variable like skewness. Kurtosis describes a particular aspect of a probability distribution. There are different ways to quantify kurtosis for a theoretical distribution, and there are corresponding ways of estimating it using a sample from a population. The standard measure of a distribution kurtosis is a scaled version of the fourth moment of the distribution. Moments about zero. Firstly, we want to find moments about zero. We denote the moment about zero by the symbol m of 0, like this. And the moments about mean. There are two types of moments about zero and moments about mean. We denote the moments about zero by the symbol m of 0 and the moments about mean by the symbol. Firstly, moment about zero. The definition or the formula of the moments about zero, the first moment about zero is denoted by m1 of 0, and it's equal to summation xi from I equal 1 to n divided by n. That is the x bar of the mean. So the first moment about zero is the mean. The second moment about zero equals summation xi squared over n. And so on. The third moment about zero equals summation xi cubed over n. And so the fourth moment about zero, m4 of 0 equals summation xi to the power 4 divided n. And we can find the moments, the rth moment about 0 by the formula summation x to the power r over n. Moments about mean. The moments about mean, we denote the moments about mean by the symbol m, but the moments about 0 by the symbol m of 0. Okay, moments about mean, it denotes m of mu or m of x bar, or for simplicity m. m1 is the first moment about mean and it's equal 0. m2 the second moment about mean and it's equal to m2 of 0, the second moment about 0 minus the first moment about 0 squared. It's the sigma square and it's known by variance. That's the variance. So we can write variance equal m2 second moment about mean, or second moment about 0 minus first moment about 0 power 2. m3 the third moment equal third moment about 0 minus the third moment multiply minus 3 multiply the first moment about 0 times the second moment about 0 plus 2 multiply m1 first moment about 0 power 3, and so on. m4 the fourth moment about mean equals the fourth moment about 0 minus 4 multiply m1 of 0 first moment about 0 multiply the third moment about 0 plus 6 multiply the first moment about 0 power 2 times the second moment about 0 minus 3 times m1 the first moment about 0 power 4. Here the first, second, third, fourth moments about mean. We want to find the first, second, and third, and fourth moments. About zero and about mean. For the dataset, this dataset, the sample size of the dataset 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. N equals 15 is the sample size. And then we can calculate the Skewness coefficient. So we find we construct a table from 4 columns. The first column, the data xi, and the second column x power 2, the third column x power 3, the fourth column x power 4. This data 1, 2, 3, 3, 3, 3, and 2, 7. X power 2, we squared each value. 1 squared equal 1, 2 squared equal 2, 3 squared equal 9, and so on. Cube, x power 3, x cube, 1 cube equal 1, 2 cube equal, and so on. X power 4, 1 power 4 equal 1, 2 power 4 equal 16, 3 power 4 equal 81, and so on. We find the summation of xi, 1 plus 2 plus 3 plus so on, plus 7 equals 60. And the summation of xi power 2, x power 2, 1 plus 4 plus 9 plus 49 equals 272. Summation xi power 3 equals 1 plus 8 plus 27, and so plus 216. It's equal 1344, and so on. The summation xi power 4 equals 1 plus 60 plus 81, and so on. 2 plus 204, 2401. This sum equals 7112. So the moments about zero, first moment about zero equals summation xi over n, it equals 60 divided 15 equals 4. Why 15? Because n equal 15, the sample size of the data equals 15. M2, the second moment about zero, summation xi squared from the table, from the second column, equal to 272 divided n divided 15, it equal to 18.30. And M3, the third moment about zero, equals summation xi cube over n from the third column, 1345 divided 15 is equal 98.6. And the fourth moment about zero, that's equal summation x power 4 from the fourth column divided n, it's equal 7112 divided 15, that's 474.13. Then we can find Kurtosis coefficient as Ku equals M4, the fourth moment about mean divided standard deviation to the power 4. The standard deviation equal, the rule of the standard deviation equal M2 about 0 minus M1 about 0 power 2, and that's the after the square root of this. The square root of M2 of 0 minus M1 of 0 power 2 equals M2 of 0, 18.13, minus M1 of 0, 4 power 2, 16, 18.13 minus 4 power 2 is 16. The square root of the difference between them is equal square root of 2.13. That's equal 1.46. M4 equals M4 of 0. M4, fourth moment about mean equals fourth moment about 0 minus 4 times. This is the rule. We substitute in this rule from the values M1 of 0, M2 of 0, M3 of 0, M4 of 0, and we can find M4, the fourth moment about mean, that will be 13.01. Then Kurtosis equal M4 over 6 power 4, 13.01 over 6 power 4, 1.46 power 4. That's equal 2.86. The Skewness coefficient Sk equal M3 over sigma cube M3, the third moment, the rule of the third moment about mean equal the third moment about 0 minus 3 times first moment about 0 times second moment about 0 plus 2 times first moment about 0 power 3 and substitute by the values of m3 of 0 and m1 of 0 and m2 of 0 and so on. We can find m3 third moment about mean equal 7. So skewness coefficient equal m3 about mean equal 7 divided by sigma standard deviation power cube 1.46 power cube, that's equal to 2.20. To meet again, for my best wishes, Dr. Saeed Hamid.